Hi ladies and gentlemen, it's Mr. Green again, and we're back with geometry and another lesson in our geometry lessons. So here we go. Where should we all be? Unit 4 should be in the dust. We should be working on Unit 5. Last few lessons in Unit 5. Making quiz corrections. Don't forget to do those. It will help your grade. Due dates. We're approaching the end of the semester. Due dates are very important. You get anything that's falling behind, going to be a 0. That hurts your grade a lot. You want to get those taken care of. Okay, on to the lesson. One of the things we discovered when we were doing constructions was that if we took a circle that drew from a particular point, a circle was all the points that were within a certain distance from that point. And so the question came up, well, how do we find distance? And what we have to do is we use a formula for circles. Well, what is a circle? Well, the formula for a circle is really kind of difficult for me to explain to you at this point. So I can't give you the formula for a circle. But what I can do is show you that we can use the Pythagorean theorem to solve a problem. Okay? And one of the things about a Pythagorean theorem is we have to have a right triangle. So if I have 2 points and I draw a right triangle between those 2 points, like that, I know that I can use the Pythagorean theorem. And the Pythagorean theorem says that I can take this distance here, I'll call it A, and this distance here, B, and I can find the distance between them. I'm just going to call it D. So what am I going to do? I'm going to take A. You know what? I've got a A for this, and I've got a A for this. This one is at 2, and this one is way down here at -5. That's the difference in the y's, isn't it? So I could say -5 minus 2 as my y differences. My x differences, that'd be these values here, wouldn't it? One of them is at 4 and one of them is at -3. And so that's going to be 4 minus a -3. I just found these distances, didn't I? This one is 7, and this one is 7 going that way too. Actually, it's -7, but since we're going to square it, it's not going to make a whole lot of difference here, is it? -7 squared is 49. This over here is 49. And this distance over here, I noticed that they're both the same. So it's actually going to be 7 square roots of 2. Okay? So I can actually figure this out, can't I? Look at that. It works out to be, well, they didn't work it out with the 7 square roots of 2. But if you took 7 times the square root of 2, you're going to get this 9.9. Okay, that was my 45, 45, 90 triangle that I was doing there again. I didn't like using the Pythagorean theorem. We can use this with any number of points. And if you come to Class Connect, what I'll do is I'll assign you a point and ask you to find the distance from that point to another point. We'll see what we come up with. What I'm going to do here is I'm going to find the distance from E to the origin. Well, where's the origin? The origin is at 0, 0, right here. And I want to find the distance from E to that point right there. Well, here's E, and here's the origin right there. So what am I going to do? I'm going to make certain I draw my right triangle so that I can figure this out. I'm going to take the difference in the x values. Well, x in this situation is a 4. And the x at my origin is a 0, so that's going to be 4 minus 0. That's going to be 4 squared. And the other one, I'm going to take the difference in my y values, and the y value here is 4, and my y value at the origin is 0, so that's going to be 4 minus 0, or 4. And that's going to be 16 plus 16, or the square root of 32, and that's going to be 4 square roots of 2 which is off the top of my head, something that I don't know because I don't remember my square root of 2 multiplication facts all that well. I get 5.65. Approximately 5.65. Cool. So we now have a formula that we can use to find distance. Okay? So I've got several sets of problems that we will work together. Okay? And when you come into class, we will work several of these together. Okay? See what we come up with. Cool. Okay. Now, can we use this to help us with a triangle? Yes. They're wanting to know, is this triangle an equilateral triangle, an isosceles triangle, or a scalene triangle? What would be the definition of an equilateral triangle? If all the sides were the same. What would be the definition of an isosceles? If 2 of the sides were the same. And a scalene, none of the sides are the same. So what can I do? I've got x and y and z. I'm going to take x and y, and I'm going to find the distance from x to y. When I do that and solve it down, I get 4.47 approximately. I'm going to find the distance from y to z. And I'm going to put that into the equation for distance and solve it down, and I get 6.32. And finally, I'm going to take the distance from z to x, and I'm going to find that distance. Put those numbers in and solve it down, and what am I going to get? I get 7.21. Next thing I'm going to do is I'm going to compare each one of these. Is that equal to that, equal to that? Nope, not an equilateral triangle. Are any 2 of these the same? Nope, it's not an isosceles triangle. It must be a scalene triangle. How could we use this if we had quadrilaterals? If I had 4 points that were given to me as a quadrilateral, I could take the ones that are in opposite corners and find their distance and find out if they were the same. That would tell me if the diagonals were equal distance, equal length. Hey, if we have equal length diagonals, that would tell me if I've got a rectangle or if I've got a square, right? Rectangle or square. Both of those would be equal length diagonals. That's what we can use this for. Guess what you're going to have to do when you get to the part 2? Yep, you're going to have to do some of that. Okay? Here's the parallelogram theorem. Okay, so we got quadrilateral. It has these vertices, A, B, C, and D. Determine, is it a rectangle? Well, if it is, then my diagonals will be congruent. So I take A and I put C, and I find the distance of A to C, and I get 11.66. And I take B and D, and I find the distance from B to D, and I get 11.66. Since the diagonals are the same length, diagonal, same length, that tells me it is a rectangle. It might be a square, but we weren't asked to find that. We were just determining if it was a rectangle. Cool? Okay. So, how would we use the distance formula to help us find the area? Well, we know what the formula for area is. It's base times height, right? But our problem is we weren't given the base or the height there, and it's kind of cattywampus, isn't it? So what we need to do is we need to find some distances. We're going to use the distance formula to find the distance from A to B. Why A to B? Well, that will tell me the height of the rectangle. And by plugging in the locations, the vertexes, the x and the y values, I find that AB is equal to 4.12. I can then do the same thing to find the distance for A to D. That would be a base. And I could then find that that distance is equal to 8.25. Once I have these two values, this 4.12 and this 8.25, I can take them and multiply them together to find the area. And that's what we're going to do here. multiplying them together, the length times the width, base times the height. And what do we get? 33.99 square units. I hope you can see how we're using that distance formula to solve some of these problems. How about for the area of a trapezoid? Same sort of a thing. If we weren't given the values, we can at least use these points to find that distance right there. You know what? I'm lazy. I'm looking at this and I'm seeing that this is going to be a distance of 5. And I'm looking at this down here and I'm seeing that that's going to be a distance of 9. And I can see that the height is 3. I can see already what we're talking about. We're talking about 21 units, right? Anyone else have any problem with that? I mean, it's pretty obvious to me that we're talking about 21 square units. But if we were following this because it was not on the grid exactly, what I would have to do is find the distance from E to C. E to C. And if I find that distance, I find that it is 5. Okay? And if I go ahead and I find the distance from B to D, I find that its distance is 9. Well, I counted them, or I used the distance formula. Both of them worked out to the same numbers. Okay? And then I find the height. Well, to find the height, I'm going to find from E to F. And that distance was 3. So we now know the height and the two bases. We plug it into the formula for area for a trapezoid. And I take 5 plus 9 is 14, divided by 2 is 7. 7 times 3 is 21 square units. Obviously, I did that one much faster just by counting the units than I did by using the distance formula. But you could have a trapezoid that's at an angle, tilted a little bit. It might make a difference for you, and you'd be able to use the distance formula following that example. How about this one? They say find the area of the unshaded region. Well, this is kind of what we were talking about when we were talking about circles a little bit here. We want this yellow portion out here. How are we going to find that? Well, we're going to have to use the distance formula. Okay? How are we going to use the distance formula? Well, we're going to find the distance from Y to Z. And when we find that distance, we find out that it is 4 units. Since we know that this quadrilateral is inside of the square like this, it must be a square. And if all the sides are 4, we can find the area of that gray area. That'd be 4 times 4, or 16 square units. Got that. Now we have to find the area of the circle. Well, to find the area of the circle, we need to find the radius. So I'm going to go from X to Z. They went from X to Y. We'll go from X to Y. And they find the distance from X to Y to be the square root of 8, or 2.83. They can now use that square root of 8 in the formula for finding the area of the circle, and they get 25.15 square units. Okay, so we're real close here, right? We got 25 for the circle and we got 16 for the square. We can now subtract those two differences, subtract those and get their difference, and see that there's a difference of 9.15 square units. Didn't think there was that much, did you? But it's quite a bit of distance in there. That's the type of problems you might be seeing. Okay? So, having shown you how to find distance, we will be using that a lot in second semester. So this is one of those things where you need to learn it so that you can use it later on next semester. Don't forget, I appreciate you guys telling me that you're in geometry and what section number you're in. It really helps me to find your records and answer your questions a lot quicker. I appreciate it, and I'll look for you next time.